Determine whether the graph is a circle, a point, or non-existent. In order to do that, you're going to have to look at the radius. And for a circle, that's what we've seen so far. The radius is going to be greater than 0. So any circle is going to have a radius of greater than 0. But if you think about shrinking a circle down to where the radius equals 0, that's going to be a point. Just think about it. You've got a circle, you shrink it down, radius 0, that's a point. But if you keep shrinking it down and the radius somehow becomes negative, well, that's impossible. That can't possibly be a thing. The circle would implode, and so we'd say that's non-existent. So when they ask you this question, determine whether it's a circle, point, or non-existent, they're basically asking you about the radius. So we want to do kind of the same thing as what we've been doing, completing the square. So gather your x's and leave space. Gather your y's and leave space, and also subtract that 12 over. So take a second and convince yourself that that line is equivalent to what we started with. Looks good, so let's complete the square. Filling in those blanks right there is completing the square. How this works is you take this number right here and cut it in half. That's -3. Square that number, that's +9. And so if you think about factoring that, two numbers are multiplied to 9, that -6 are -3, -3, but that's going to factor into x minus 3, or x minus 3 squared. I just completed the square over there. Similarly over here, cut that in half, that's 1. Square it, that's 1. Factor it, you get y plus 1 squared. And so I have completed the square. But also what I've done is thrown my equation out of balance. Remember a second ago when I asked if that line was equivalent to what we started with, it was, but now it's not because I've added 10 out of nowhere. So what we're going to do, you could either add 10 to the right side just to balance out the equation, or subtract 10 from the left side. Either way, it's probably going to make more sense to you if we do it this way. I added 9 and 1 to the left, so let's just add 10 to the right and keep it in balance. Gathering those like terms, -12 plus 10 is -2. And so we can see the center radius form of the equation right there. And so what it looks like is a circle with center at 3, 1, or 3, -1. And, wait a minute, that would say it's a radius of square root of -2. That can't happen. That's going to be an imaginary number. We can't have a radius that's an imaginary number. So this is non-existent. Example 6. Okay, there's 3 receiving stations at 1, 4, -6, 0, and 5, -2. Record distances to an earthquake epicenter of 4 units, 5 units, and 10 units, respectively. Find the epicenter of the earthquake. Okay, so we've got one of these circles has a center at 1, 4, and a radius of 4. That's what they're saying right here. So let's go ahead and draw that. Center at 1, 4, and a radius of 4. I wonder if I can draw a circle with that. And that's not how that works. That's not very good. Okay, that's pretty good. So then there's another one at -6, 0, and a radius of 5. So let's try that. 1, 2, 3, 4, 5, 6. Right there's the center. And let's try this again. Whoops. Radius of 5. Kind of hard to do this. Probably should have just used a hand. Okay. That's pretty good right there. Radius of 5. Up, down, left, right. And then let's do the last one. Center at 5, -2, and a radius of 10. Center at 5, -2. Let's try this again. Okay, so that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Not sure why that's not on the center. 1, 2, 3, 4, 5, 6, 7, 8, 10. Five, 6, 7, 8, 9. That's almost right. 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. Not quite. Pretty close. That's pretty close. A little bit bigger. Okay. All right. So we've got our three circles, and we're looking for the epicenter of the earthquake. So how this is going to work is we need to look for a point that's on all three of the circles. So circles are pretty good. I don't know if I could have done it better by hand, but you can see right there, that point right there appears to be on each of the three circles. So if you notice, the coordinates of that point are -3, +4. That seems to be what we're looking for. Okay, -3, +4 would be the epicenter. Okay, we think, assuming our graph's good enough. Okay. So really what we should do is solve this algebraically. So take that blue one and look at this information. We should have an equation, x minus 1 squared plus y minus 4 squared equals 4 squared is 16. That's the equation of that blue circle. So plug in -3, 4 and see if it works. Okay. So if I plug in -3 and 4, I would get -3 minus 1 is -4 squared. -4 squared. And then over here, 4 minus 4 is 0 squared. That should equal 16. Well, that's 16. 16 plus 0 equals 16. So what that tells me is that the point -3, 4 is on the blue circle. Okay, well, let's try the red one. Same thing for the red one. You'd have a red equation, x plus 6 squared plus y squared equals 5 squared is 25. And so let's take that point, -3, 4, and see if it works. Well, -3 plus 6 is 3 squared, and then we'd have 4 squared. That's going to be 9 plus 16 equals 25. Okay, good. That works. So that means that that point is also on the red circle. So now guess what? We're going to do the same thing for the green one. Let's see if that point is on the green circle. So we would have x minus 5 squared plus y plus 2 squared equals 10 squared is 100. And plug in that point, -3, 4. -3 minus 5 is -8. So square that and you get 64. 4 plus 2 is 6. Square that's going to be 36. And yeah, sure enough, 34 plus 36 equals 100. And what that means is that point is also on the green. So we can kind of tell from the picture, but we can definitely tell from the algebra that the point -3, 4 is on all of those circles. And so what that means is -3, 4 is the epicenter.